So the security team over at Project Zero has been doing a lot of work, and among the things they've discovered is a bug in several of the ways that CPUs do predictive analysis or speculative prediction. To give you an idea of what speculative prediction is, if I start saying A, B, C, D, E, you would probably go F, G, and so on. In the basic summary of this would be the processor will use prediction to try and figure out what needs to be done next in a way to be more efficient. That is a really basic explanation for a very complicated way this is done, because you're talking about so many CPU cycles and thousands of processes that all run in parallel. Now, running all these processes in parallel ideally should mean they're all separate and they all don't talk to each other. So the tools running my or holding my passwords or programs on my computer don't get to talk to this website, for example, unless I want them to. And that's where this comes in as a pretty scary bug, because the concept is this, that you would go in here and run a piece of software, let's say some JavaScript, and it would be able to escape that where all the processors run their own little thing or doing everything in parallel with each other, but supposedly not talking to each other. Well, they found a way to pull information from one process to the other, and of course, somewhere within there is my password I use to log in, which means this is a hell of a security threat. Now, over at Michael Schwartz, he has a proof of concept of this. He's one of the security researchers involved in it. So using Meltdown to steal passwords in real time, Intel bug. He's got all the hashtags in here. He's showing that, yes, using this methodology, he made a little animated GIF here that's really cute. I'll leave links to all this in there, showing that, yes, he was able to make this happen. So proof of concept. So you start with the idea that could this happen? Proof of concept. Right here, he's showing it and gives all the details. Now, vulnerabilities start with, this was found about 6 months ago, and they've been working with the processor companies and the kernel developers and all the people writing software to start mitigating this a while ago. And it took until January here. So if you jump over here, Project Zero, you can see that this is reported as an issue back in June of 2017. So this has been around for a little while, but the way these projects work, the security researchers give time to companies to patch the problems that they find. This is a really big problem, so they've given lots of time to patch. Now, where the big concern is versus a lot of vulnerabilities is because this is in the hardware of more in Intel, so the Meltdown variant affects more of the Intel processors versus Spectre one affects all the processors. So this is a hardware level problem. And it gets a little bit deeper because there's microcode updates and things that need to be updated on the processor to mitigate it. The short term, we're going to have software mitigation, as in kernel patches and things like that. Now, Microsoft released their patch for Windows 10 on January 3rd. And on January 9th, you're going to be able to get the patch for all the other supported operating systems. Sorry that I know of. I don't think I've seen Windows XP in this list. So if you're still running a non-supported Microsoft operating system, this is going to be a problem for you. But the patch is available. I tested it. We tested it on Windows 10 machines, and we've been updating it for our clients. So far, knock on wood, had no problems doing the update, no safety risks. I've also updated my Linux machines, and everything's being patched. So it is a big deal. There is a proof of concept out there, but if you're running a single user machine, it's less likely to be attacked, but that is never a reason not to patch. So patch as soon as you can, and if you work in IT, you're probably already busy patching all of your client stuff, because once a threat is out there, it's a matter of time before someone builds a stack of threats on top of it to really make this exploitable and scalable and much more scary than it is. So most of the scaredness is because it really could go bad. Now, the other concern of this, and this will be inside of, this is actually the kernel. I'll leave links to this as well. And this is from Linus, the kernel developer on Linux, Linus Torvalds. And he's saying something around a 5% performance impact for the isolation. What they're having to do is isolate this cool predictive thing that was really efficient. And when they isolate it more, it becomes less efficient. So we see problems with slowdowns. And of course, we want our CPUs to be as fast as we can and not slow down. So we're seeing a 5% slowdown according to Linus for certain workloads and almost no slowdown for others. So it's really use case dependent. So if you're running a gaming system and everything's running what they refer to as user space, and you're using the computer, single desktop like mine right here, and it's used for single tasks that don't make a lot of kernel calls, yes, you don't see much of a slowdown. You're good. But this is where things get a little hairy. So if this is another kernel developer, Willie Taru, and he says, I'm seeing as much as 17% on an enterprise level application. Now, enterprise applications, such as hypervisors and larger scale virtualization systems are used in Azure, they're used in AWS, they're used at the data center level. When you really don't want problems there, you don't want one virtual machine escaping to another virtual machine or being able to read memory from it. So this is really scary at the data center level, and we're seeing much more of a performance impact. And that's unfortunate because no one wants to see data centers turned down a notch. That's pretty scary. Now, there's some more analysis, and I'll leave a link to these guys as well, over at Phoronix. They're continuously benchmarking and analyzing the x86 PTI issue on more systems. And they're going to probably break some more of this down. These guys are testing experts. I'm not, so I'm not going to try and run any benchmarks or pretend I have a setup like they do to do all this major testing. So I'll leave a link to them. They're doing all this work and all the testing and figuring out, what causes the problems on a slowdown and what is not. Because it's kind of a crapshoot. These companies can do the patches and fixes, and we literally have to benchmark them to see what the differences are before and after the patches. So that's still going to be an ongoing process. Also, these are the first iterations of the patches, so there is a chance that someone will go, oh, there's a better way to do it than the way we implemented it. But the process is security first, and then we work on optimization, which unfortunately I think that's how this occurred. There wasn't a lot of security first going on here. Now, the other thing to note is Intel realized that this could be a problem, so they actually had a little bit of foresight that there may be a problem, and they have some instruction sets in some of their newer chips that kind of allow to help partially mitigate this. So the older Intel chips, when this is back to speculation on my part and on other security research parts until we can get the test results in, that there is going to be more of a slowdown on the older processors, a more performance hit because it doesn't have facilities to do this. Now, AMD and ARM are affected. ARM is what runs our cell phones, so these are affected. So we're going to have to see patches for a lot of the cell phones, and that goes for Apple and Android as well. I'm not as clear or if there's any proof of concepts at this moment for the ARM or on cell phones, but it's still theory that can be done. The difference in the ARM, as I understand, is it's a switch you can flip off. In ARM, and I believe that's on their documentation I read, that you can just turn off speculative read with just take a performance hit, but it can be turned off, not by you, but by options in the system. So we're going to have to wait and see how those patches come along and how vulnerable they are. This is just a very new story and lots of testing. And because of the way it works, it's a very complicated issue. So we have to tread lightly here on how we do this, because if it's as bad as we are worried about, and the proof of concept on certain processors that we've seen says it's really, really bad, it really does have a dramatic effect on overall systems, the data center, and things like that. And that's where a lot of concern is. Seems to be a little bit less risk on the desktop because we have Google coming out with a patch, I believe, for Chrome on the 23rd, and I think Firefox just released one today. What they're going to do is, so programs running here, because it relies on timing issues, they're basically going to introduce a little bit of noise in that timing to make it really hard for those programs that might be running to try to escape memory and get in there. There's not clear, but the antivirus companies look like they're trying to update and look for this. This is the unfortunate side of antivirus. It's a cat and mouse game where we have to look for a program doing it so we can isolate the program doing it and then be able to block it, so we have to be able to identify it. So far that I've heard of, as of today, we haven't seen any of this in the wild, which means we don't see any of these proof of concepts that some of these security research done in the wild, running around stealing all the passwords and jumping out of virtual machines and making a mess of the internet. So far, unless the NSA has been doing it in a very low-key, quiet way or some other three-layer agency, we're not aware of it in the wild, but it doesn't mean you shouldn't patch, because it's a matter of time. And this goes back to things like WannaCry, where it was not in the wild. We had a patch for it because we found about the vulnerability, we had a patch for it, but then when the WannaCry was put together and they threw all the threats together, it went wild on the internet long after a patch was available. So patch now, because those who don't patch will probably be seeing going wild on the internet a few months from now. Someone will put together a big exploit and take advantage of this. So like I said, the simple thing is get patching, make sure everything's up to date, but you should be doing that anyways, because that is how a lot of these bugs and things like that get out and are out there. You can read all the white papers. Like I said, I'll leave the links to everything in the description below for the Meltdown attack and a Spectre attack. they gave very detailed breakdowns of how it all works. And one side note, because someone mentioned this, yes, I'm aware, but I don't know the implications of it, that one of the Intel, I believe he's an engineer, sold stock while knowing about this, but before public disclosure. That's a no-no. It's referred to as insider trading because they realized the Intel stock would go down. And, of course, the AMD stock went up. Not going to bother with that. You can look that yourself. I don't know where the laws are on that. It seems like it's illegal, but I'm not an expert or an investment person. But if you're curious about that, yes, I'm aware of it. But I'm going to focus on the security side, and we've been spending time making sure all of our systems are patched for our clients and for ourselves, because that's what's really important, is making sure that you stay secure. All right, if you like the content here, like and subscribe. Leave your comments below if you want me to be more active. Join our forums on the Facebooks, because YouTube comments suck, and I'll keep saying they suck until they stop sucking. Thanks.